All right, hey, good afternoon, everyone. My name is Chris Galaska. I'm a network engineer for the U.S. courts. I work out of the Third Circuit Court of Appeals from Philadelphia, but I'm local here. I just work remotely from Charleston, going to Philadelphia every now and then. But I've been a network engineer for close to 20 years. Well, I'm not engineer exactly, but been working in networking for about close to 20 years. And so I'm going to talk today about enterprise network design with a security-minded approach, because it is a lot easier to design your network with security in mind from the start than it is to try to go back and retrofit an existing network with a secure configuration. So let's just talk about it. This is what I'm going to go over today. I'm going to talk about device hardening, network segmentation, network access control, and then get into some of the newer technologies with centralized device monitoring and management, and then also give you all some tips on what to look for if you're selecting a network performance monitoring tool. All right, so with that said, we're going to start with device hardening. The thing to remember is that even though all of your networking devices are intermediary devices, they're switching and routing traffic throughout your network, they are still nodes on the network, and so they need to be secured themselves. It's easy, I think, for people to understand and to conceptualize that you have to secure your servers, you have to secure your workstations, you have to secure your applications, and they kind of don't think about the networking equipment as it goes along. You know, it's just that's the road. Everything else is driving on there. We're only worried about the things on the road, but it's also important to make sure that your networking devices themselves are configured in a secure manner. So the very first thing that I always look for when hardening devices is just to make sure that the software is up to date with the current recommended version. I know that that's a very simple thing, but if you look at most of any manufacturer's security advisories, they're going to say, hey, this is a vulnerability. How do you fix it? You fix it by updating the software. It's fixed in a new version of software. So that's the first thing I do when I'm designing a network. Before I deploy any equipment, I make sure the software is up to date. Next thing I do is make sure that I do secure command line configurations on all of my networking devices. So every manufacturer, I've been working with Cisco pretty much exclusively for my whole career, but any manufacturer is going to have a device hardening guide. It's going to tell you everything that you need to know to disable unused protocols, to disable insecure protocols, different things where, hey, if you don't need this service, turn it off. Here's the specific situations in which you might need that service. If you're not meeting any of those, just disable this service because it's vulnerable. So just simple things like that. Just follow the manufacturer's guide. And then I don't know how many in here have ever been in the military. Disastigs are built off of all of that. So you just follow along. Hey, disable that. Configure this like this. Next, for remote access into your networking devices, make sure that you use SSH, not Telnet. The reason why you do that is SSH is encrypted and Telnet is completely unsecure. So all your management traffic that you're passing from your workstation to whatever networking device you're trying to configure is all unencrypted. So always SSH version 2, and always follow the device hardening guide as far as the configurations go for SSH for user session timeouts and things of that nature. Next thing is your actual users. When you log on to your networking devices, if you have a TACACS server, use a TACACS server to do actual network account. It integrates with Active Directory. You can use a specific administrator group that you have for other administrative activities. You can allow specific administrators access into your networking devices using those credentials. You get, logging then exactly who's logged in. You make sure that the password policy that's on your normal Active Directory environment for your administrator accounts is followed, and all of that. It's the best way to do it. Not everyone is going to be able to do a TACACS server. That's just the reality of it. So if you do end up using local accounts, it needs to be identity-based. You shouldn't have shared accounts. You shouldn't be multiple administrators logging onto a single account called admin. Everyone should have their own account. And then every device should also have a AAA policy that specifies, password minimum lengths and special character usage, password expiration, things like that. The same kind of policy that you would put in your regular network. If you can't bring your Active Directory environment into your network management environment, then go ahead and follow that same policy on the local switches. Lastly is your security vulnerabilities. So most of us have some kind of software that we use to scan our devices, scan workstations, see what kind of Windows patches you need or servers or whatever. The same process applies for all your networking devices. Scan them, apply fixes. If it's fixed with a configuration change, then go ahead and take that new configuration and apply that to your secure baseline that you put on all of your networking devices. And these are just some basic steps to harden your devices before you get to configuring anything specific. Every single networking device should have a secure baseline that you put on them before you get to host names, IP addresses, VLANs, or any of that. Next thing is network segmentation. So it's pretty simple. People have been doing VLANs for years and years and years, but if you try to put everything in one VLAN, you're creating an insecure configuration, and eventually you're going to have to go back and fix it. So again, much more difficult to retrofit, so just design it secure from the start. All of these are different types of traffic or device types that you might want to configure your VLANs for. So your straight user data, voice, video, wireless, your servers, your management, any security appliances you have, IoT devices, all of these different types of devices should be separated out into different VLANs. There's a lot of good reasons to do that, like security. Everyone says, oh, you do your VLANs for security. Yes, but it does not inherently add security on its own just to make VLANs. If you put a bunch of VLANs on your network, they're all coming out of your core switch or your router or wherever it is, there's going to be inter VLAN routing, so there's no security inherent, but there are a lot of benefits that are inherent just to creating VLANs. One is organization and ease of management. So if you have different IP address blocks that are assigned to different types of devices, then it's very easy to look at a glance and see this IP address is in this range. So, oh, that's coming from one of my temperature sensors, or that's coming from an end user workstation or my wireless VLAN, etc. So just organization, ease of management. The next thing, obviously, if you have one big network, then you have a very big broadcast domain. Broadcast storms become an issue, and more devices can be affected by a broadcast storm. So by breaking your network into smaller segments, you can break up your broadcast domains and you can limit broadcast traffic that way. It's easier to apply specific QoS settings. So you need your voice VLANs to have different QoS settings, video, different QoS settings. If you're doing AV over IP or you're doing virtual desktops or any of that kind of stuff, and you have specific QoS settings, if they're in different VLANs, then you're able to more easily apply those QoS settings. And then the last thing is actually how it ties into security. If you're breaking your VLANs up by device type, then you're more easily able to apply additional security such as access control lists to a specific IP address range and actually provide some security. Next, so I'll talk about something real quick before I get into VRF. A lot of us work in multi-tenant facilities, and in multi-tenancy, at some point, it is likely that you will have some shared resources, some shared network resources, whether that's at the core switch or an access layer switch or maybe the router, or even you're just sharing a firewall or whatever. At some point along the line, unless everyone has their own equipment that goes all the way out to their own separate internet connection, you can have some shared resources. So if you do have a shared resource, and in this example, I've got a shared core switch, one thing that you can do to keep traffic from one company, from being able to go to another company is to use virtual routing and forwarding. And so what it does is it has different physical connections to whatever the next hop is. And in my example here, it's a firewall. So different physical connections for each organization to the firewall, and then they are logically separated. Their routing tables are completely different. Essentially, it creates 3 different routers on that core switch for the 3 different organizations. They're completely unaware of the existence of the other organizations. They only know how to get out to the WAN. They don't know how to get left and right to the other organizations. So this is one way that you can handle multi-tenancy if you have shared resources like this. Another way that you can do it that is slightly less dynamic and a little bit more complicated to configure is to use access control lists. So with an access control list, you are going to block traffic based on IP address. It could be source or destination IP address. If you're using an extended ACL, you can get a lot more granular than that. You can actually block traffic based on the port number and protocol that it's using, the TCP and UDP ports, I mean. But in this example here, again, just multi-tenant facility, there's just an access control list on the core switch that would block all of the traffic from company 1 from being able to get to company 2, but it can still get out to the internet. And so that's done by IP address, and it blocks everything. It's just a full-on block unless you're using extended ACLs that get into only blocking or only allowing specific protocols. If you continue here, so even if you don't have a multi-tenant facility, you still have different areas of your network, especially your management VLAN, your server management, your like your AV devices, your IoT devices, some kind of critical infrastructure that you don't want your standard users to be able to get to. An access control list is a good way to block that traffic. So let's say you have any of this critical infrastructure stuff, especially a management VLAN. You only want to allow specific users here. So there are 2 different ways to do an access control list. You can either only block certain things and then allow everything else to go, or you can only allow specific things and you automatically block everything else. And so that is actually the kind of thing that you would want to use if you're protecting critical infrastructure. So you would have your, let's say your IT VLAN or a jump host, your SolarWinds Polar, those kind of things that need access to that management VLAN, you'd allow them. And then everything else would be just completely blocked from being able to get to there, which it does get tricky when you talk about VPN connections. So if you had an administrator who's connected via VPN, they need to get to a networking device. In that case is when you would use a jump host. So from their VPN connection, they would use administrator credentials to hit like a Windows server that's dedicated as a jump host, and that device would be allowed in, because you don't want to just open up that access control list to the entire VPN. You don't know what IP address your administrator is going to get when they are connected remotely. Here's some examples of how to configure an access control list. Again, this is Cisco commands, but the one on the left is if you're going to restrict access to critical infrastructure. This is very simple. This is a standard access list. I'm just only allowing specific things. And so I've got in the remarks there, the first one, allow the IT VLAN to get in, allow the SolarWinds polling IP, and allow our jump host server for anybody who's remote, and just like that. And everything else is automatically denied. On every access control list on a Cisco switch, at least, there's an implicit deny at the end. And so if you look on the other side, where I'm only trying to block specific IP addresses coming from one company to another company, I'm blocking their entire IP address range, and I've got to permit any on the other side, and that allows all of my traffic to get through. So that's these very simple, basic ACL examples, but there's a lot more that you can do with them. It's just the more that you do with them, the more careful you have to be, because if you block something that you didn't mean to, you can cut someone's access off. So this is the kind of thing you definitely want to test before you put it in, especially if you're using extended ACLs, and probably don't make a change to an access control list in the middle of the working day. All right. So that is that. And next I'm going to talk about our cloud management, or on-premise actually, centralized device management. So the way that networking has worked traditionally for years and years is that an administrator has to log into a switch or a router or whatever and make configuration changes. So if you have mass configuration changes, you have to log into each device and make that configuration change. The same with your software updates and everything like that. Of course, it's been possible for a long time to write a script to log into all of your devices and say, hey, I need to update the NTP server on all my switches. Okay, well, I've got 112 switches. Just run this script. It's going to log in for me and change it on all of them. That's great. But it's still, every single switch has its own control plane, and you still have to make contact, even if it's an automated process, make contact with every switch. And every switch has the data plane and the control plane on the same device. Newer technology using an on-prem solution, which could be an actual piece of hardware or a virtual appliance that you run in your own like VMware environment, it takes the control plane out of every switch. And nothing changes on the network side. So all the traffic is still routed and switched exactly as it was before. That's now just called the underlay network. And then there's an overlay, and the overlay is where all the control is. So you have one centralized platform that you log into, and you can configure new network devices. You can monitor all of your hardware, like actually monitor the hardware itself too, not just, like, is it up, is it down, give me SNMP traffic, but actually monitor the power supplies and fans and all that kind of stuff. It does automatic inventory. It does automatic generation of, forgot the word, sorry. It can, documentation. Oh, just right on my slide, it's right there. So automated network documentation. You can do your software updates from there. So you can actually, from a software-defined networking architecture, you don't even have to be full SDN, but if you're just using a controller-based piece of hardware, you can pre-stage an iOS update. So you've got 100 switches. You can say, okay, cool. Well, tonight we're going to be doing this block of 25. I'm going to schedule them to update. The software is loaded to the controller, and it's just going to push out all of those. It's going to send me updates and say, hey, it's in progress. Hey, switch 1 is done, etc. This switch had a problem. I'll try to reboot it or whatever. It's just going to take care of the whole thing automatically and saves a lot of time, and it actually makes that critical part of doing your software updates a lot easier. So that's one thing that I've noticed just in years of doing network stuff, is that actually updating the iOS falls through the cracks sometimes, unless there is like a critical security vulnerability that you need to update for, because there's no workaround. But it's very easy to just like, I don't really want to schedule that maintenance window and then log into each of these switches and do this upgrade. So having that process automated from a controller really enables administrators to more freely update, and just way more easy process. Can also do policy compliance audits. So we talked about the secure network baseline earlier, about making sure that you're following that guide for device hardening or whatever. So you put that in your controller and you say, this is my baseline. Any device that comes onto the network, plug and play, is going to get that baseline. If anything changes on there, it's checking them. It's say, hey, this one's out of compliance. It has HTTP web access enabled. I'm like, oh, okay, well, let's fix that. And then the last thing that you can do with it is software-defined networking. Software-defined networking is its own beast. That is like the next level. So you can do all these other things already without even getting into software-defined networking. But once you go to software-defined networking, and again, I'm only really familiar with Cisco's, which is their DNA center. But once you go to that, you can move to like an entirely identity-based networking model, in which a user logs in and they're giving what's called a secure group tag. And so now, instead of having to do access control list, and I say, this is my administrator's VLAN, and it can get to my management's VLAN. Well, it's just like, there's Chris Galaska. He is an administrator. So whether I'm connected on the VPN or on the wireless or plugged in at my desk or plugged in at someone else's desk on the 6th floor, it sees me and it knows which network segments I have access to. And so those things are done through identity instead of based on IP address. It's not something that you can do in a vacuum. It takes other resources. Identity Service Engine from Cisco is one that I've used, and it takes a lot of configuration. But once you get it set up, you can have like a true identity-based network access solution in addition to all these other network management automation tools that you get. So, and all of that's on-premises. The problem with the on-prem solution is that controller is really expensive and the licensing is really expensive. A virtual appliance is a lot more affordable. Licensing costs still the same, but at least you don't have to pay like $40,000 for the actual hardware appliance. Another way you can do it is to do a cloud-based network management. You get almost the exact same tool set and almost the exact same benefits. It's just that instead of having a controller that is yours and just yours on your network, it is a cloud-based solution. So again, the one I'm most familiar with is Cisco's. They bought Meraki several years ago, and they have that as their cloud-based network management solution. So how that works, it's the exact same thing. The control plane is separated out of the networking device. Network underlay remains the same, but now instead of going to a controller that is at your site, it goes to their cloud managed network, wherever that is and whatever data center it is. The big thing to keep in mind with this though, because I think a lot of people are probably iffy about the security of like, well, I'm going to send my traffic to the cloud, right? It's like a lot of security concerns about the cloud. Well, all of the traffic that goes from your devices to the cloud is just management traffic. It's no user data ever goes through there. All the user data is still routed along the normal means. Now, of course, your device configurations are up there, but everything is encrypted. It's all encrypted in the data center at rest, and everything is encrypted as it is sent. Any kind of configuration changes you make, usernames, passwords, or anything like that. One recommendation that I would make if you do use a cloud-based network management solution is to set up two-factor authentication. Put that in your security policy too. So hey, anybody who is going to be an administrator of this system must use two-factor authentication to make sure you audit for that, and that'll just give you that extra layer of security. It can be easily done with like Duo. And that is all I've got on that. So lastly, this is the last thing I've got for you guys. So now I'll talk about network performance monitoring tools. So once you have your network in place, monitoring is a big important factor to try to maintain the security and maintain the efficacy of your network. There are a lot of tools. There are really expensive tools that you can buy. There are open source tools that you can learn. Whatever you choose to use for this purpose is going to be up to you. There's too many solutions to even recommend one. Like everyone here is going to be familiar with SolarWinds. SolarWinds super popular for this purpose. There are other tools like Cisco has a secure network analyzer that is a NetFlow collector and analyzer that does a lot of automated secure baseline and like anomaly detection and things like that. So it's just going to be based on your requirements, your budget, and then your level of expertise. There's a lot of open source stuff that requires Linux knowledge, so I'm out on that because I don't know Linux to save my life. But a lot of you might, so just keep an open mind, do your research. But here's some things that I look for in a network performance monitoring tool. SNMP, super basic, sending information from your devices to a server. Always use SNMP version 3 now, as I'm sure everyone in this room is familiar with the SolarWinds breach from a few years ago. That was a version 2 problem. And a lot of people were still on version 2, even though version 3, I don't know how old it is, probably 15 or 20 years old, but a whole bunch of people were still on version 2. Another thing I like is syslog, which I rely a lot more on SNMP from a networking device than I do syslog, but still, if you have a need for syslog, make sure you keep that in mind. Packet capture, there are tools, like you can use Wireshark and do your packet captures, but there are other network management tools that have packet capture built in. And you can, look for those, or deep packet inspection, which is essentially the same thing as a packet capture, except for it looks deeper into the traffic, and it doesn't just give you like source and destination IP address. It tells you about application and TCP and UDP information that you might not necessarily see. NetFlow, like I talked about, NetFlow is awesome if you actually want to know what's happening on your network. So SNMP will tell you what's happening with your devices, but it won't tell you who's talking to who. It won't tell you what information is being sent from where to where. And that is what NetFlow does. So it looks and it'll say, hey, there's an active TCP connection from this IP address to this external IP address. And if you have a good NetFlow collector and analyzer that does get a baseline of your network, it can alert you to anomalies. Which would be great if you had a breach and there was, just suddenly this machine is just like offloading information, offloading data from a file server to some unknown source. Like, oh, that doesn't normally happen. Just like, something's wrong here. Here's an anomaly, that kind of thing. Telemetry data, I love telemetry data because it tells you about your actual devices. That it'll tell you, like the temperature of your devices and how the power supply is doing and how your CPU usage is looking and things like that. So I love telemetry data. Root cause analysis is super useful because maybe you have a port that keeps flapping and you're like trying to figure it out. Like, I've got this port that keeps flapping. Why does it keep flapping? Why does it keep flapping? There are tools that can look in the logs and use the various logs that are available, and it can tell you, well, it's actually flapping because of this misconfiguration. This is your root cause. And so having a tool that can do root cause analysis for you can save you a lot of time as an administrator. Because like you might look and you say, well, it doesn't matter. It like the port flapped and users didn't notice anything, but it keeps flapping. And like, what is actually happening? Let's get to the bottom of it and actually stop the problem. Another thing I like is if a tool has customizable dashboards, because there are certain things that I care about as an administrator. There may be certain things that other administrators that I work with care about more. And so having customizable dashboards, it's not one size fits all. And then the last thing, automated alerting. I love automated alerting. I don't want to have to like specifically log in to each of these services, especially if I'm like out and about and my off time. Automated alerting is great. I get an email or a push notification or whatever. You can get a text message from some of these things. Just send you a text message, hey, this device is alerting for this reason. And so that brings my attention to where it needs to be without me having to spend all day just like staring at the NPM dashboards. So, alrighty, that is all that I've got. Does anybody have any questions? I went way too fast, I think. Yes.
What certifications do you recommend? Do you recommend getting certification at all?
Well, it depends on what you're trying to do. But I've just done Cisco certifications. I had CCNA, just route switch, and that was plenty. They've moved since I did it. They've moved a lot of what was in CCNA into CCNP. You don't talk about EIGRP at all in CCNA anymore. So if you actually wanted to be a route switch person, I think maybe the CCNP, take the core and then the advanced routing and switching one would be the route that I would go. I like vendor training. That's what I like. So if I want to know about Meraki, I want to look and see what training Cisco has available for Meraki and do their courses. And so it's just like that with whatever it is you want to do. I like to look at vendor specific things. And you don't have to get the certification. I know like when people are looking for jobs, certifications are great. But when you're actually working the job, having a certification doesn't really mean more than just knowing how to do what you need to do. But continual training is important because the technology keeps changing, it keeps growing and evolving, and you need to stay up to date or you'll just have all of your devices in VLAN 1 in 2023. Anything else? Yes.
Quick question. So when you said, you mentioned software-defined networking,
Mhm.
is that the same as infrastructure as code?
I have not heard the term infrastructure as code.
Cloud.
Cloud? Oh, cloud. So software-defined networking is the on-premises, and so then the cloud base would be what you're talking about. And Cisco calls their software-defined access. So if you see that term, it's just software-defined networking. But Cisco has two different technologies for the WAN side and the LAN side, and they call the LAN side software-defined access and then SD-WAN. And whereas Meraki is just Meraki. You can do your WAN, your LAN in one interface, and your wireless and your monitoring, like cameras and stuff. It's awesome. Cisco has a very fun habit of just buying what they like. Splunk is a great example that just recently happened. But yeah, I went to some Meraki training maybe 5 years ago, and the Cisco engineer was telling me, yeah, we started building our own cloud solution in-house, and it was hard. And so then we just said, who's got the best one on the market right now? And then we bought them. So that's how they like to do business.
They bought the flip cameras back in the day.
Yeah.
Maybe they put that in telepresence, I don't know. They don't
So
sell them anymore.
no, we're on to WebEx codecs now, WebEx Pro or whatever. I can tell you with that, I would not buy a WebEx codec unless I really needed some of those features because it's so much cheaper to just use like a laptop. And you're vendor agnostic at that point. You can just plug in a good camera and a good microphone, like a little mini desktop PC. Like it's easy. Any other questions? Alrighty. Well, thank you all very much.